So for question 55, we have 3 parts, and for each part we have to solve for t. So for a, let's take the natural log of both sides. ln v to the negative 0.3 t equals ln of 27. Well, this is a composite of a function and its inverse, so we get back negative 0.3 t equals ln of 27. Dividing both sides by negative 0.3, we get t equals negative ln of 27 over 0.3. Well, 27, by the way, is 3 cubed. So that's going to be the ln of 3 cubed over 0.3, and the sign's negative. So we can bring that 3 out in front, and we get negative 3 times ln of 3 over 0.3. So, oh boy, things are going to divide out here. I'm just going to move this decimal over 1, so consequently I have to move this decimal over 1 and put a 0 here. And so 3 goes into 30 10 times, so that's going to be negative 10 ln of 3 when the smoke clears. So now let's go on to B and see what they give us. And B is e to the kt equals 1/2. E to the kt equals 1/2. So we'll take the natural log of both sides. So we have ln of e to the kt equals ln of 1 over 2. And now, since this is the composite of a function and its inverse, we get kt equals ln of 1 minus ln of 2 if we break that up using the law of logs. And so ln of 1 is 0, so now we have kt equals 0 minus ln of 2 is minus ln of 2, and now we'll divide by k, and we get t equals minus ln of 2 all over k. And we've got that one done. Finally, we've got one more to go, so I'm going to erase this. We're going to do C.
Favor, how are you?
Yeah, and C, e to the ln of 0.2 e to the ln of 0.2 t equals 0.4. Well, you know, that is the same as e to the t times ln of 0.2, which equals 0.4. So we could go a couple of ways here. I could say, well, by the law of logs, that's e to the ln of 0.2 to the t power, which equals 0.4. Now, this is the composite of a function and its inverse, so we get 0.2 to the t power equals 0.4. And now if we take the natural log of both sides, we get ln of 0.2 to the t power equals ln of 0.4. Now we can bring that t out in front and we get t ln of 0.2 equals ln of 0.4. So dividing through by ln of 0.2 we get t equals ln of 0.4 over ln of 0.2, and we're done. Good. Now there's another way to do this question 55 also, and that's just take the natural log of both sides right from the start. So we have ln of e, and this is going to be t ln of 0.2 equals ln of 0.4. So this is a composite function, so now we have a function and its inverse, so ln of 0.2 equals ln of 0.4, and finally t equals ln of 0.4 over ln of 0.2, and that's a little quicker way to get to the solution.